All right, here we go. Here we go. So this is gonna be a two parts notes, guys. Tomorrow we'll do well, this is we're gonna be able to do all of these, but tomorrow we'll do like a second iteration of this. In the beginning, some kids find this kind of hard. It's really simple, guys. Like if all we're doing is we're taking the derivative with respect to x. If it's not an x, you're gonna write dy dx on it, and you'll see what I mean in a little bit. So let's see. Let's see what it says. First, we define the difference between implicit and explicit. Explicit is a function that is described clearly, like y equals square root of x. So that's what we've been dealing with all this time. We've been dealing with explicit functions. An implicit equation is in the form of y squared equals x, so it's not y equals something. Not all implicit equations can be written explicit. Let's see if we can do example one. You guys ready? Notice that in example one, they want dy dx, right? I'm gonna go really slow. This is like quote unquote chain rule. It's not, but it's like. You can write it like this. I guess, well, okay. How should I do? Oh, yeah. I already started. It's too bad. So you can write it like this. So it's like saying that. So if I were to tell you to take a derivative, what would you do to take the derivative of the left hand side? You would move the 2 to the front. You would leave the inside alone to the power 1. And then we would say the derivative of the inside, right? That's a y, so the derivative of the inside, you can say y prime, or you can say, we're going to say dy dx for now. And the derivative of the inside, which is dy dx, which equals, and then what's the derivative of x? Just 1, yeah, that's it. Was that hard, guys? No, that's it. And so making it nice and pretty, 2y dy dx. And again, it's like chain rule, but not really. People don't call it chain rule. They just say we're taking the derivative implicitly. Divide by 2y, and you get dy dx equals 1 over 2y. And you are done. That's a derivative. Notice that this time my derivative has y's and x's on it, or in this case, just y's. So that's a big difference. So if we were to solve this explicitly, so let's start with y squared equals x. I'm going to take square roots of both sides. So I'm going to go y equals the square root of x. And I'm going to rewrite that as x to the half. Now let's take the derivative. Dy dx equals, bring the half to the front, x to the negative half. That's how we did it in the past. So 1 over 2 square root of x. Chavez, this is not the same as this. Yes, it is. Look right here. Square root of x is equal to y, or y equals square root of x. So this is the same as 1 over 2y. Do we see how it's the same? Isn't that cool? Why you no like? No, for real. What's going on, guys? Tell me. Ms. Rowe, do you like it? Do you like this? Implicit? Oh, let the record show she nodded. It's actually pretty fun. Watch. You just need more problems. So, well, not that we need more problems in our life, but we just need to do more problems. So look, example 2. Actually, I think I stole this question from like a UT Austin or one of those. So check it out. I don't think UT Austin said it with a circle. They just said find the slope. I would hope that you know that this is a circle. This is a circle centered at origin. Circle centered at origin with what radius? Yeah, with radius 5. We will do it explicitly in a little bit. Let's go ahead and take care of it implicitly. So if I want the slope of a circle, that means I'm looking for dy dx. Notice what quadrant you're in. 3, negative 4, you're in quadrant 4. So if you're in a circle, here it is, 3, negative 4. So the slope better be positive, right? So here we go. I'm looking for dy dx, looking. So here's how you start. You start with the expression. So I'm going to put start with expression. X squared plus y squared equals 25. So a lot of you, especially in the beginning, are going to be writing y prime equals. Do not write that. Look, we don't have y equals. It's x squared plus y squared equals 25. Is everyone cool right now? All right. What's the derivative of x squared with respect to x? 2x. Done. Plus, that plus is this plus. What's the derivative of y squared? 2y, but is it an x? So what do I write right next to it? dy dx. If it's not an x, you write dy dx right next to it. Cool or not cool? Equals, what's the derivative of 25? 0. Done. It turns to a game of algebra. You're solving for what? Dy dx. Move that 2x due to the right. So 2y dy dx equals negative 2x. And then I'm dividing by what? 2y. Dy dx equals negative x over y. They wanted the slope at 3, negative 4. Dy dx evaluated at 3, comma, negative 4 equals negative on the outside, parenthesis, x on 3 divided by negative 4. Negative divided by a negative is a positive, so my slope is 3/4. What do you guys think? Okay, don't worry. I'm going to solve this the way that you guys have always been solving this. So if we did it explicitly, it would look like this. So x squared plus y squared equals 25. I haven't done any calculus yet. I move the x squared to the right. Y squared equals 25 minus x squared, and I take a square root. Y equals plus minus square root 25 minus x squared. I look at where I'm at. I'm at 3, negative 4, so I'm looking at the bottom half. So I'm looking at the negative one. So I go y equals negative square root of 25 minus x squared. I haven't done anything. I haven't done any calculus yet, guys. All I've been doing is algebra. Negative on the outside, parenthesis, 25 minus x squared, close it to the 1/2. Y prime, or dy dx, equals negative on the outside, negative 1/2, parenthesis, leave the inside alone, to the power negative 1/2, times the derivative of the inside, negative 2x. Negative times a negative is a positive. That negative 1/2 cancels out with that negative 2. So I'm going to have x in the numerator, and the denominator I'm going to have square root of 25 minus x squared. Is everyone still okay? All right. Y prime evaluated at x equals 3 is equal to x over square root of 25 minus 3 squared. 3 squared is 9. 25 minus 9 is 16. Oh, I put an x when I should have put a 3. 3, sorry guys. 3 over 25 minus 16. The square root of 16 is 4. So I got 3/4. OMG, did I get the same answer? Well, it's easier. I think it's easier to do the red. The AP exam, well, calculus, doesn't matter how you cook it. They're going to want you to know both ways. What's up? Because I'm in quadrant 4, and the negative part is what creates the below the x-axis one of the circle. Hit me, guys. I can't read minds.
So will we get points off a certain one? Is it gonna be like use this one, use this, and if we don't do it, then it's gonna be like wrong.
Yeah. Yes. They're gonna tell you like x squared plus y squared equals something, and they're just gonna say solve dy dx equals whatever, blah blah blah, and like it will be a point like for you to do it implicitly. Now, if you can do it explicitly correct and you did everything like you got all the little details, then you can. But usually they're looking for implicit. It's very obvious when they're looking for implicit. Sometimes they'll even tell you bluntly, solve for this implicitly. There it is. Now it's just practice time, guys. So here we go. We're just going to practice. Show that the slope dy dx is defined at every point on the graph 2y equals x squared plus sine y. Defined at every point. Okay, so that just means Solve for dy dx and see what happens. See if you have a rational function and see if you can get a 0 in the denominator or something like that. All right, so let's take a derivative. So let's take a derivative immediately. So I'm going to write the expression first. 2y equals x squared plus sine y. All right, what's my first move? No, I wouldn't divide. Just take the derivative immediately. What's the derivative of 2y? 2 dy dx. It wasn't an x. So 2 and then dy dx because it wasn't an x. Does that make sense to you guys? Yeah, I'm taking the derivative of y with respect to x. So 2 dy dx. Y, what's the derivative of y? Y prime. What is y prime? Dy dx. So it doesn't matter how you look at it. It's all the same. Equals, what's the derivative of x squared? 2x. Plus, what's the derivative of sine y? Cosine y, but it wasn't an x, so what do I put next to it? Dy dx. You're done with calculus. Everything else is now just what? Algebra. Get the dy dx's together on one side. I'm going to move this dude right here to the left. So I'm going to write 2 dy dx minus cosine y dy dx equals 2x. And I'll slow down. Are we cool? Okay. What can I factor out? Dy dx. So that's what I'm looking for. You guys are on it today. Dy dx 2 minus cosine y. Not that you guys aren't on it any other day, but equals 2x. What did I do to get dy dx by itself? Yeah, divide. You guys had a good algebra teacher. 2x over 2 minus cosine y. Yeah, it's defined everywhere. How do I know it's defined everywhere? Will you ever get a 0 in the denominator? Look at it. No, cosine y, the biggest cosine y will ever be is 1. The smallest cosine y will ever be is -1. We all have pre-cal, right? Okay, so I'm going to say, let me see, what word am I going to use? 2y minus, show that the slope, okay. Dy dx is defined, can't even spell defined, defined at every point since what? Since 2 minus cosine y will never equal 0, period. It will never equal 0. That's the only way it can be undefined, is you have a 0 in the denominator. So dy dx is defined at every point since 2 minus cosine y does not equal 0. Cool or not cool? Okay. Are you guys awake? I promise YouTube, I have a class. They're just really quiet. Okay. No more yawning. That's a demerit. Let's go to the next question. Find the tangent and normal to the ellipse. Hopefully we know it's an ellipse, but if we don't, that's fine. You know what? I actually want to see this one. I want to find the tangent and the normal to this ellipse at that point. What do I need to find the tangent and the normal? A point and a slope. And once you find the tangent slope, the normal slope is just opposite reciprocal. So let's do it. You look, notice it's not explicitly. So you can't start by writing y prime equals. You have to do this implicit. You must. Does that make sense, guys? So I start by writing out the expression. Start by writing x squared minus xy plus y squared equals 7. I'm going to take the derivative with respect to what letter? X. What's the derivative of x squared? 2x. Okay, so here's where I'm going to go slow. Depending on you, if you're advanced, you can group that negative with the x. If you feel that you still need more practice, then just put xy in brackets like that, minus, and then do product rule with the xy. But if you feel that you're pretty advanced, you can just group the negative with the x. Is that clear? Okay. So there it is. I'm going to do product rule first. X times derivative of the second. What's the derivative of y? dy dx. 1y, it's not an x, so dy dx. Plus the second, y, times derivative of the first. What's derivative of x with respect to x? 1. It's actually dx dx, but dx dx is also 1. Plus, what's the derivative of y squared? 2y, it wasn't an x. dy dx equals, what's the derivative of 7? 0. Distribute the negative, it now turns into algebra. 2x minus x dy dx minus y plus 2y dy dx equals 0. And I was tempted to just move everything already, but I want to go slow so you guys can see everything. Everything that does not have a dy dx on it, move it to the right. And I'm going to put the 2y dy dx first because I like to have positive terms in the front. 2y dy dx minus x dy dx equals, let's see, the y moves over there, y minus 2x. I only had 4 terms. I got everything ready. What do I do to the left side? I factor out a what? A dy dx. Yeah, we're just doing algebra now, guys. dy dx, 2y minus x, close it, equals y minus 2x. Now what do I do? Yeah, just divide. This is a product, guys. 2y dy dx times 2y minus x. So divide. dy dx equals y minus 2x over 2y minus x. Not a big caution because we're not doing multivariable calculus. So I think if you were to do a little curl on the y, on the d, I don't think readers would take that as a partial derivative. Avoid doing this. See, try not to put hooks on your d's. That does mean something when you do multivariable calculus. You're not there. Partial derivatives, we're not even going to touch them. That's not until your multivariable professor, when he gets to you. He or she gets to you. All right. And that's it. We're done. Oh, wait. No, we're not. We want the tangent slope. We want the tangent line. All right. Here we go. I'm going to write dy dx. I'm going to write a line. That line means evaluated at -1, 2. So I'm going to write 2 minus 2 times -1 over 2 times 2 minus -1. If there are no mistakes, let's see, negative times a negative is a positive, so I get a 4 in the numerator, and I get 2 plus 1, 3 in the denominator. Here's my tangent. Tangent colon y minus 2 equals 4/3 parenthesis x plus 1. And here is my normal. Oh, yeah. I said 2 plus 1. Thank you, miss. I would have drawn the Desmos and I would have been like, what the heck? That's not a tangent. Y minus 2 equals, what's my new slope? And I think we're good. Let's see. I actually want to see how this looks. I want to see this ellipse. So let's see. Let's go to Desmos. Okay, give me the equation, the original equation, the expression. All right, guys. Focus, guys. X squared minus xy equals 7. Yeah, I like it. Okay. I want to see the point. What was the point of tangency in normal? Was it -1, 2? All right, there it is. There's my point. Let's see how cool this tangent and this normal looks. So let's see. My tangent line was y minus 2 equals, what was my slope? 4/5 x plus 1. Yep, that's definitely a tangent. Do you guys see that? Y minus 2 equals negative. All right, focus, guys, focus. 5/4 x plus 1. I love it. That is definitely a normal. Look at that. Look at that. Isn't that awesome? No, for real. This could be a meteor circling around Earth in an oval shape, and at that point in time, it's right there. It is the science that NASA uses. It is the math that NASA uses. They'll probably use more parametric and four dimensionals. IJ. They probably use vectors, right? IJK and time. All right. Let's continue. All right, focus, guys. What does this is probably going to be heavy algebra looks like? What does that mean? Everyone knows that means second derivative? No, unfortunately, not unfortunately, because we love it. We love this. I love this. We want more of it. Give me a buffet on this. Okay, I'll stop. All right, here you go. Ready? I'm taking the derivative with respect, no, just one letter. X. Okay, side note, because I want to make sure we're not robots. You guys know we can take a derivative with respect to any letter, right? Okay, so if I tell you something like z cubed, so there's a side note, and I go z cubed, and I write on the side here d dz. That means I'm taking the derivative with respect to z, right? And then you would write, what's the derivative of z cubed with respect to z? 3z squared. And you don't write anything next to it because I took the derivative with respect to z. But if I were to write d dx, I guess I tipped d dx, and I write a z cubed, and z is differential with respect to x, then you write 3z squared dz dx, because I took the derivative of z with respect to x. Okay, I just wanted to make sure, put that as a side note somewhere. Okay, here we go. Here we go. Oh. I have a very, very little headache, which is a weird one. It's kind of like the one that I had a long time ago. Really weird. I've been drinking a lot of water. I just haven't had caffeine, but I slept like 7 hours, so there's no really any reason because I slept good. I slept good, and I had like the weird, weird, weird. All right, here we go. I'm taking the derivative with respect to what letter? X. So, what's the derivative of 2x cubed? Perfect. Minus, that minus is this minus. What's the derivative of 3y squared with respect to x? Perfect. Equals, what's the derivative of 8? 0. I'm going to solve for dy dx. So I'm going to move the 6x squared to the right. So negative 6y dy dx equals a negative 6x squared. And I want to get dy dx by itself, so that means I'm going to divide by what? Yeah, negative 6y. So dy dx, negative divided by negative is a positive. The 6's cancel out, and I'm going to have x squared over y. Are we okay? I'm going to get a different color. That we're not done yet. They want the second derivative. So what rule do I got to use to get the second derivative? Quotient. So here we go. Second derivative. So d2y over dx squared equals bottom times the derivative of the top. What's the derivative of x squared? 2x minus top times the derivative of the bottom. What's the derivative of the bottom? dy dx all over bottom squared. You don't want to see a dy dx? all you're going to do is substitute x squared y into dy dx. See? So here we go. The second derivative with respect to x, so there's how you write it. 2xy minus parenthesis x. I'm going to go slow. The dy dx is x squared over y squared. So catch up to there. I'm going as slow as I can, guys. Yeah, please ask.
When you write the d squared y over dx squared, why is the d squared at the top and the x squared at the bottom?
Because it's kind of like saying d dx of d dx. So in the math world, d squared. And yeah, you're right. Maybe there should be parentheses like that, but they don't put parentheses on it. But in the math, but it's understood. It's understood. But it's understood. That's what it means. All right. Here we go. Oh, going back to blue. So 2xy minus x squared times x squared is x to the fourth. And I'm going to write a y like that over y squared. If you have colored pencils, here's a good place. I need to get a common denominator in the numerator. So I'm going to go multiply this dude by y over y. And now I get 2xy squared over y minus x to the fourth over y all over y squared. Sorry. I'm trying to show as much detail as I can. I hope that you guys are happy with all these details. Two xy squared minus x to the fourth over y squared. I'm about to do keep change flip. So my denominator, I'm gonna have one denominator, and that's my denominator is gonna be y cubed. Do you guys see that? So I'm gonna have 2xy squared minus x to the fourth over y cubed. And there it is. That is your second derivative. 2d squared over y over dx squared equals 2xy squared minus x to the fourth over y cubed. Oh, yeah. I'm thinking of a Grupo Frontera song. I'm going to heaven, I hope. All right, here we go. You don't have to start from square one. Oh, this would have been a good place to start the. Now, good thing I didn't do it today. We'll do it with smaller crafts tomorrow. The whole thing. All right, here we go. You guys ready? They already give you the first derivative, guys. They want the second derivative. So, what's the derivative of 1? 0. What's the derivative of sine? Cosine y, but is that a dy dx? Perfect. So right now, here's what I have. D squared y over dx squared equals cosine y dy dx. Plug in what dy dx is. So we're going to have cosine y times 1 plus sine y. Do I have to distribute? Yeah. We're going to have cosine y plus cosine y sine y. Oh, there it is. I was looking at A, B, C, D, and I'm like, what the heck? Done. All right. I think we got one more. Man. Oh, that's it. All All right, guys, try your handouts. I will eventually do one of them, but not yet. So I'm gonna pause this. All right, guys. So here we go. I'm gonna do number 3 for all of us. So number 2 should be the same as the notes because this is the same. The only difference is in our notes we equaled 7. So we should get the same dy dx, which I believe was y minus 2x over 2y minus x, right? And then we're going to use this for number 3. Excuse me. So I think it might take up the whole space here. So I'm going to start right here in this border. So the second derivative with respect to x is equal to, what rule do I got to use? Quotient. So bottom, 2y minus x times derivative of the top. So let me see. dy dx. I'm going to write it as y prime so it doesn't get nasty. Y prime minus 2. Bottom times derivative of the top minus top, y minus 2x. Times derivative of the bottom, 2y prime minus 1. All over bottom squared. 2y minus x squared. I think everything looks okay so far. Yeah, we're going to have to be very careful with our algebra. All right. Can I simplify it? No, I don't think I can. I'm going to have to do the algebra. All right, we're done. We're just got to do algebra now. So I'm going to go real slow. 2y times y prime. So I'm going to write 2y y prime. Wherever you see y prime, that's dy dx. 2y times negative 2, that's going to be a minus 4y. And make sure m cubed that you keep me my algebra, that my algebra is good because I make mistakes all the time. 2y times negative 2, negative 4y. I think we're good right now. Minus xy prime plus 2x. I'm just doing this. And then let's see, minus giant parenthesis 2y prime. I'll distribute the negative a little bit. Minus y minus 2xy prime plus 2x. All this is still over 2y minus x, close it squared. Okay, I see stuff canceling out, so good thing. So 2y y prime minus 4y minus xy prime plus 2x, and I'm going to distribute this negative to all 4 terms, minus 2y y prime plus y plus 2xy prime minus 2x. Where? 2x times 1. Oh, yeah. So this one right here should be 4. I did it again. That one, right? Okay. Okay. I think we're good now. All over 2y minus x, close it squared. All right. Let's see. 2y prime and negative 2y prime, 0 out. Let's see. What else zeros out? The 2x is 0 out. Let's see. What else? That's it, right? Okay, and there's only one y prime that I got to do. Okay, so I see, let's see, what do I see? Negative, I'm adding these up right here. That's a negative 3y. And xy prime and xy prime. So that's going to be a plus 3xy prime all over 2y minus x, close it squared. Okay, got it. I'm going to move this front 3x, and then where it says y prime, I'm going to put what dy dx is, which was this guy. Y minus 2x over 2y minus x. Y minus 2x over short-term memory. Y minus 2x over 2y minus x. 2y minus x. I'm do. I put this one first. Minus 3y over 2y minus x whole the squared. Yeah, next year I better put more room in here. All right, let's see. I guess I have no choice. I'm going to multiply this guy by 2y minus x over 2y minus x to get a common denominator in the numerator. And I'm going to drop it down, just like we did last time. And here's what I have. I'm going to distribute this, guys. So I'm going to write it way over here. 3xy minus 6x squared minus, I'm now doing this one. It looks again like I'm going to have 6y squared plus 3xy. Something's happening in the numerator. All over 2y minus x to the third power. So catch up and let me know if there's any hiccups. Yeah, this is why the algebra is the hard part, not the calculus. Oh, what's up? Oh, I keep change flip. You see how in the numerator I have 2y minus x? So it's kind of similar to this one. Let me show you. Similar to this one right here. See how on this one I made, I had these y's right here, and I did keep change flip, and I had y cubed. So it's the same logic. So I had 2y minus x on this one, and then 2y minus x on this one as the denominator. And then because I was running out of space, I just moved it down, and I already had a 2y minus x squared. So it turned to 2y minus x to the third power. That makes sense? Okay. I think we got it because it looks beautiful here. So you know what? I bet you, because I remember vaguely. Yeah, man, those guys are so tricky. All right, so I'm gonna factor out. Is there one that's doubled? Doesn't look like it. Okay, add them up. 3 and 3, and I'm gonna write it like this: 6x squared plus 6xy plus minus 6y squared over 2y minus x to the third power. What am I going to factor out in the numerator? Oh, wait. Oh, yeah, negative. Yeah, the both. Yep, yeah. This one's positive, this one's negative, and there. Now we're good. And then what am I going to factor out in the numerator? But a negative 6, because look, these guys are so tricky. I didn't make this problem up. I got it from somewhere. I'm going to factor out a negative 6, and you're going to get x squared minus xy minus y squared all over 2y minus x closest to the third power. And at first, you're looking at all the answer choices, and you're like, it's not in there. But look at this. So catch up to there, and then we'll talk. Man, look how tricky these guys are. This expression right here, x squared minus xy minus y squared equals 1. They hate us because they ain't us. Okay, I'll stop. I know that was as lame as it gets. I won't do another one. All that equals 1, guys. So my final answer is negative 6 over 2y minus x to the third power. Is that one in there? Look at those guys. Yeah.